So chapter 3 is the sine and cosine laws. The first thing I'm going to go over is the sine law, and then I'll go over the cosine law. So I'll just run through some examples. The formula that you might know is sine A over A equals sine B over C, and it actually continues on to say sine C over C, and these are all equivalent. The proof of how to do this is in your book. I'm not sure it's that important, so I've chosen not to go over it. I do go over it a little bit in the notes, the written notes. I'm not going to go over a video of it. So here we have this relationship between the angles and the sides. Notice that the angles are labeled with uppercase letters and the sides in lowercase letters. The side with lowercase letter is right opposite the angle. So for instance, if I labeled this triangle A, B, C, right across from angle A, I would have side little a. Right across from angle B, I would have side little b. And right across from angle C down here, I would have side little c. So notice that the sides are labeled with lowercase letters, and they're right across from the angles. That's just notation. Basically what this says is that if you take the sine of the angle divided by the side across from that angle, it's going to be equal to the ratio of the other two sides, or the angle on the side. So this is how I do this. I start this off, I say, okay, well, sine of this angle down here, which is 63, divided by the side across from it, which is 18. And this is important because for the sine law to work, I must have a complete ratio. At least one ratio must be complete. So here I have an angle and a side, and I have both those values. This is going to be equal to sine of 58 over the side that's opposite that angle, which we're calling x, because I don't know it. That's what I'm trying to solve for. So next thing I do is a bit of calculator work. I need my calculator. I have to do sine 63 on calculator using degree mode. So I have 63, then I hit sine, so I get 0.891. So 0.891 divided by 18 is equal to sine of 58, which is 0.848 over x. This is how I solve these things. There's a couple of ways to do them. I use cross multiplication. So I multiply the top by that bottom and this bottom by that top. So I end up getting 0.891 times x is 0.891x, which is equal to 0.848 times 18, which is 15.26. And then for the last step, we have to divide by the 0.891. That's just using algebra. 0.891 on both sides. So I take my value there, divided by my 0.891, and I end up with 17.13. So x is equal to 17.13. And that is the length of this side over here. That's what we found. So that's the first example, running through the sine law, how to set it up, and what you need. And that's how to solve for a side, a missing side. Next example I'm going to work through here is, I'm missing an angle this time. Okay, so we set it up the same way. Notice that I don't have any labels here, and it doesn't really matter. All I need to know is that I have an angle up here, and I have a side that's right across from that angle. So I set that up. I say sine of 39 over 21 is equal to sine of theta, which I don't know, over 24, because the 24 is right across from theta. So next thing I do is I solve these. I'm going to solve this one a little bit differently this time, because what I can do is divide these two values. I can take sine 39 and divide it by 21 to get a value of 0.0299. So let's say 0.03. So it's 0.03 is equal to sine theta over 24. Remember, I'm trying to solve for sine theta. So how do I get rid of the 24 in the bottom if it's being divided? I have to multiply it out. So I times by 24 on both sides. 24's cancel. The reason that I'm doing it this way is because it's kind of nice. I don't have to, I'm rounding on paper, but on my calculator I'm not rounding at all. I'm keeping the value on my calculator and I'm just going to work through the math. So I take that value and times it by 24, and then I have 0.719, which is equal to sine theta. And do you remember how to solve for angles? I have to do the opposite of sine, which is actually sine to the -1, the inverse of sine. So I have to take sine to the -1, or the inverse of sine of both sides. On the right side, I'll be left with just theta. On the left side, I'll have my angle. Notice again, I haven't done anything on my calculator, so I'm not rounding at all yet. I'm keeping it exactly the exact answer. And all I have to do is I have to take the inverse of sine. So I take inverse sine, and it comes up with 45.99. Now that's fairly accurate. I would assume that if I rounded and worked out my rounding answer, it probably would have come out to about 46. And you could round this to 46 degrees as well, but it is nice to have an exact answer.